Tomorrow, I'm going to start writing detentions for unprepared for class if we don't pay our fines, okay? So if your name's up here, you need to take care of it. After class, not right now. X plus 2y equals 4. 2x minus y equals 3. We are solving these systems using the procedure dictated. This one says substitution. Now you have done this since first year algebra. Substitution means look at your equations. Get one, in one equation, get one variable by itself. Please always choose a variable that doesn't have a coefficient. So either get this x by itself or get this y by itself. It would be much easier, I think, to get this x by itself. So I will subtract 2y and write x equals 4 minus 2y. You with me? Now, this is what x equals. So when I see an x in my other equation, I'm going to replace it with 4 minus 2y. Remember doing this?
Yes.
So my new equation then, when I cut that out and paste it here, my new equation will be 2 times 4 minus 2y minus y equals 3. It's the whole equation with the x taken out and the 4 minus 2y plugged in. So 8 minus 4y minus y equals 3. Everybody see the distribute? So 8 minus 5y equals 3. Now what will we do? Subtract the 8. So we have negative 5y equals negative 5. And y equals 1. Now, your job is not to find y. Your job is to find the point where these two lines cross each other. These are lines. And if you graphed them, they would cross each other. Where do they cross each other? At some point. What do we know about that point now? The y is 1. So all we need to do is find the x. And we'll find the x by plugging in y. And you can plug it in anywhere you want. I like to put it in my box. So I got to turn my phone off. I forgot to turn it off. So if I plug in 1, then x will be 2. That's the answer to the question.
So you don't have to graph it.
You don't have to graph it. No graphing necessary. You are just going to find the ordered pair. And you're going to write it as an ordered pair. This is how the answer will be expressed. 2, 1. Now, I want to skip to another substitution. So number 3 is a substitution. Please do not freak out. This one has a squared in it, but you're still substituting. And when you substitute, you have to get one letter by itself. Guess what? It's already done. So we're going to take this, and we're going to substitute it in for that y. So it will be that top equation. Now, because I'm plugging this in, that top equation will say x plus 1 squared equals 5. Now you know what to do. Foil. Somebody said foil, and whoever said that is right on target. We are going to foil. So x plus 1 times x plus 1. We're going to foil that. So that will be first, outside, inside, last. Whoa. What kind of an equation is that?
Excuse the interruption. Can I please have Bryce Akers report to the front office?
Yes, indeed.
Thank you.
Hurry back, Bryce. Please hurry back.
All right.
This is a quadratic equation. So let's get it set equal to 0 and collect like terms. So I got an x squared. What else do I have? 3 x's. Now subtract that 5, so that will be
This is for I'm confused. How did you get the x plus 1 squared equals 5? Oh, never mind. I was on the wrong problem.
so we have minus 4 equals 0. How do I solve this equation? This is harder than our first example. I factor it. Does anybody see how this thing factors? X.
Oh, x plus 4, x minus 4.
Perfect. Which means x is negative 4 or x is 1? Now wait a minute, how are we supposed to write our answers? Ordered pairs. So you're going to have 2 of them this time. One of them has an x-coordinate of negative 4, and one of them has an x-coordinate of 1. Those are both x's. So there's 2 answers this time. We'll talk about y in a minute. How do I get the y's?
Plug it in.
Plug them in. If x is negative 4, then what would y be?
3.
Negative 3. How about if x is 1? 2. Why did I get 2 answers? Anybody want to take a guess at it?
Squared.
Well, this is a parabola. X squareds or y squareds are parabolas. So you have a parabola and a line, and they are intersecting in 2 places. These are the 2 places.
Wait, how'd you get the negative 3 and 2?
If x is negative 4,
Oh, got you. Okay.
and I plug it in to get my y. All right, there's one more substitution. Let's do that one together. And in fact, maybe there's a volunteer who would like to come up and do number 6.
Jabron.
All right, but I need you calm and attentive, Jabron, not crazy, okay? Come on. All right, Jabron is going to do problem number 6 while you are doing it at your seats. How are you going to begin?
I have to get one of the equations, one of the variables by themselves.
Exactly, so you're gonna pick which one makes the most sense.
I'm just gonna switch this 4 and this y around. So I'm gonna put x minus 4 equals y. I subtracted the 4 over and added y.
Okay,
So that's my little equation.
okay,
I'm gonna plug that in for x. So I get 2y minus 2, 3.
okay, now I need you to be careful, because you solved for y. So
Oh,
you
okay.
need to be plugging that in for y. Does that make sense to you?
Wait, he didn't do, wait, x minus y equals 4, doesn't that have, that'd be negative y.
No.
What? You got asked.
He added y and subtracted 4. I probably would have just added y and substituted for x. Yeah, so that'll work. But he's correct.
Alright, so that's my little thing. I get 2x minus 8 equals, and just minus 2x equals 3. Then I'll combine my terms. I get
Those cancel, so you get.
Something very strange happens here. Did you notice it?
What's the setting up for this?
You can't do it.
There's no solution.
What happens with 2x minus 2x?
It cancels out.
It's gone. So you have negative 8 equal to 3. Does negative 8 equal 3?
It's no solution.
It's no solution. These two lines are parallel, which means they don't
Intersect.
cross, so you have no points of intersection. When you lose your variables like he did, and you get a statement that is not true, negative 8 equals 3, not true, then you have no solution. Maya?
If it was 3 equals 3, then would it just mean that x-axis?
No, it would mean they were the same
I get 3
line.
bottles of water.
And so basically it would mean they were just always intersecting, because they would be exactly the same line. Great question. Thank you, Brian. Okay. All right, now, you'll remember from your work back in algebra class that you do not have to do substitution. There is another process called elimination. So let's practice that one. Let's look at number 2. The idea is the same. We want to end up knowing where these things intersect. But we're not going to substitute this time. We're going to eliminate. Now, does anybody remember anything about that? Tyler?
Don't you have to get, like when you have to multiply 2 by something so that it equals like x below it, so that they cancel out?
Yes, you need to make either your 2 x's match or your 2 y's match. Either one, doesn't have to be x, it could be y. But you want to make a match with one positive and one negative, so that when you add them together, they will eliminate. So, do you have a thought on that? What might be? If we multiply the bottom by 3, then it would become 15x plus 3y equals 72. Notice I am multiplying the entire row by 3. Now the top row I'm just going to leave alone. But do you see why they suggested doing that, you guys? When you add them together, the y's are eliminated. That's the purpose. So 17x equals 85. Just adding, straight down. So x equals 5. Now again, you are not finished. Your job is to find the ordered pair. You now know x is 5. So what do we do to find y, Katie Baumgartner?
Plug in 5 for x.
I plug that 5 in for x, and I can put it in anywhere I want. So if I just go back to the top equation, if I put in 5, I'll have 10 minus 3y equals 13. If I plug in 5 into the top equation, and you can plug it in wherever you want. So negative 3y equals 3, and y equals negative 1. So your answer is 5 comma negative 1. Do you remember that process?
Yes.
All right, let's look at number 4, and then we'll have a volunteer come up and do number 5.
Can I be the volunteer again?
No, not unless nobody else wants to.
Nobody raise your hand.
Okay, let's not be bullying.
I'm not bullying, I'm just giving out suggestions.
Now, I know this equation has x squareds in it. Do not let that bother you. You are going to eliminate either x squared or y squared, whichever seems easiest to you. It doesn't matter. So taking a look at that system, what do you think? Multiply the bottom by 3. That may or may not have been your idea, but are you okay with that? That will accomplish what we want, won't it? So here we go. Bottom equation, Gibran. I need you to be quiet. So we have 6x squared plus 3y squared equals 18. All the way across by 3. Top equation hasn't changed. Is this going to work for us? Because these are going to cancel. They're going to eliminate. So 7x squared equals 7. X squared equals 1. What does x equal?
Quick question.
The second. What does x equal?
1.
Plus or minus 1. Remember, when you take the square root, it can be positive or negative. So we're going to have 2 answers. X is 1, x is negative 1. Okay, Jabron.
Could we have just multiplied at the very beginning, multiply the top equation by 2?
Negative 2?
Negative 2.
Yep, remember, they have to eliminate.
Yeah, I'm
So,
just
yep,
smart.
yep, that would work out fine. Yep, that would work out great. Now, where do I go from here? I plug it in. So if I plug in to my top equation, it's going to say 1 minus 3y squared equals negative 11. So negative 3y squared equals negative 12. Y squared equals 4. So what does y equal? 2. Plus or minus 2. So guess what? You didn't get 2 answers to this problem. You actually got 4.
Okay, see,
What are you confused about?
I'm not confused, I just don't approve.
You don't approve?
This is just a lot of stuff.
It is, I know. Jack?
We just write one answer that's plus or minus 1, and then plus or minus 2.
You can in this case because they all go with everything. So you could write it this way, absolutely.
You cannot put it up in front of the parentheses.
No. By the way, the reason that happened, and this is, we're going to talk about this later on, but the reason that happened is you have a hyperbola and an ellipse. And how many points do a hyperbola and an ellipse intersect in? 1, 2, 3, 4. All right, do I have a handy-dandy volunteer to do problem number 5? Is anybody feeling like you could do problem number 5?
I only see one hand. I only see one hand.
Now, here's your hand. Okay, now wait a second. I want everybody to notice.
You want to help me?
I want everybody to notice that I rewrote the second equation when I wrote it on the board. When you are doing elimination, you have to have your x's and your y's lined up. Do you see how I wrote the equation a little bit different? We're looking at number 5. So I had to line everything up so my x's and y's were on top of each other. Okay? If I'm doing elimination. Yes, Ethan.
May I shout out the answers?
No.
What, why are you going there?
Let's let Kieran.
What does that mean?
Oh, now Ethan will take, because Kieran says, look what happened. I'm doing elimination and everything eliminated.
Whoa.
So we are left with basically 0 equals 0. Erase that, honey. Erase that. And write 0 equals 0, because that's what you got left with, right? Nothing on the left equals nothing on the right. Now, think about the problem Jabron did. He got -8 equals 3. Okay, that's not true. But this one says 0 equals 0.
That is true.
It's all solutions, right? These are the same lines, so what you write is the same line.
Every time you call something out, you give me really tricky problems for what I'm catching on.
Now, you need to understand the difference because this will happen. If you lose all of your variables, if you lose all of your variables, which both boys did, two things can happen. You can be left with a false statement, -8 equals 3. That's no solution. That doesn't even make sense. Or you can be left with a true statement, 0 equals 0, 2 equals 2, 5 equals 5. That means that both of your equations, instead of doing this, they're right on top of each other. They're the same line. Got it? Just write the same one. Tonight you're going to get a chance to practice that, but we need to do a couple other things. Turn to page 44. We're going to have some new vocabulary. Did you guys study matrices last year?
I did watch the Matrix.
I know you have an idea. We are going to be charged with solving bigger systems of equations. What you have done so far is solve today. We have solved systems that have 2 equations in it and 2 unknowns. They have 2 equations, an x and a y. We figured it out. We will be doing equations that have maybe 3 equations and 3 unknowns. So they'll have x, y's, and z's. Or maybe 4 equations, 4 unknowns, a's, b's, c's, and d's. And we're going to use matrices and our calculators to accomplish that. Can anybody tell me what a matrix is?
According to the movie, it is a code of. Is that even halfway right?
You can see some matrices on the paper, like matrix A looks like this. A matrix, by definition, is a rectangular array of numbers arranged in rows and columns.
That's not too far off.
The language of matrices and vectors is a little bit different. So we will have a vocabulary section on our test to make sure you understand the vocabulary of matrices and vectors. So what is a matrix? It's a rectangular array of numbers arranged in rows and columns. Now, when we look at the matrix, these are the rows and these are the columns. So rows go sideways and columns go up and down. And that makes sense to you because, like, if your house has columns, they go up and down, right? If you go into church, the rows are sideways.
Cornfields.
Cornfields, yes. So rows, columns. Got it? Now, we classify matrices by their dimensions. Some books refer to the dimensions as the order of the matrix. The dimensions of a matrix are the rows by columns. And when we say this, don't say times. It's not rows times columns, it's rows by columns. Just like if you were going to give the dimensions of this room, you would say it's 30 by 20, right? That's the dimensions of the room. A matrix is rows by columns. So the dimensions of this matrix, how many rows does it have? 2. How many columns does it have? 2. So it's a 2 by 2. When the dimensions match, like they do here, 2 by 2, we call that a square matrix. So a square matrix has the same number of rows and columns. So on your paper, look at matrix B. What are the dimensions of matrix B?
3 by 2.
Rows first. How many rows?
2.
2. How many columns? 3. So matrix B would have dimensions 2 by 3. Is matrix B square? No, because it's 2 by 3. They don't match. The entries, also called elements, are the numbers inside the matrix. Now, this is where I really need you paying attention. Let's go back to matrix A. If I wanted to talk about this number right here, that number, here is how I would refer to it. With a little a, that tells me it's in matrix A, and the subscript on it would be 2, 1, because that number is in the second row, first column. And remember, when I'm in matrix land, the row number is always first. So if I want to talk about this guy right here, I'll use a little a because he's in matrix A. That's how I know which matrix to look in. And then I'll say second row, first column. So second row, first column, that's 3. As opposed to this, which would be a whole different number. This would mean first row, second column. So what number's in that spot? First row, second column.
0. Oh, that was.
There's no 0
Oh, I
in this
thought
thing.
we were looking at B.
Oh, no, yeah. So Gibran has pointed out that, okay, if I am looking at a different matrix, like matrix B on your paper, if I said find this, whoops, find this, you would all be able to do it. What does that mean? Second row, third column. So which number would I be talking about? 4. The 4. All right, we'll finish this tomorrow. You have homework tonight. Let's get off to a good start.
Brooke, can you find some so I can get this to
Yeah.